2.0 grams of sulfuric acid react with sodium carbonate. How much mass of sodium carbonate is required? So our reactants are sulfuric acid and sodium carbonate. Acid, that means I'm going to have hydrogen as my cation. Ich equals 8, so I'm going to have sulfate as my polyatomic ion. So I crisscross. H2SO4, acids are aqueous, plus sodium carbonate, Na plus 1, carbonate CO3 minus 2, crisscross. Yields. Okay, so this, when you see a carbonate, it's not a straight double replacement reaction, because that carbonate gets broken down and carbon dioxide gets released. So anytime you see carbonate in your reaction, when it's like this, acid and a carbonate, you're going to get a carbon dioxide. And then the other stuff kind of still falls out the same way as an acid-base reaction. Remember, when you have an acid and a base, you're going to get a salt, which just means an ionic compound, and water. So for this reaction, we still have the acid, we have a carbonate, so we're going to get carbon dioxide, and then we still get that salt and water. Okay. And our salt would be our cation and our anion, so sodium sulfate, okay, and water. Okay, sulfates are soluble, so I have a little aqueous tag there. All right, and let's balance this. We have 2 sodiums and 2 sodiums, so actually that might fall out on its own. 1 carbon, 1 carbon. Okay. 2 hydrogens and 1 extra oxygen. Actually, I think this one comes out balanced. Let's just double check at the end. 2 hydrogens, 1 sulfate, 1 sulfate, 2 sodiums, 1 carbon, 3 oxygens, 2 plus 1. So there we do have that balanced chemical reaction. All the coefficients are 1. So it's 1 mole of sulfuric acid reacts with 1 mole of sodium carbonate to form 1 mole of carbon dioxide gas, 1 mole of sodium sulfate in solution, and 1 mole of water as a pure substance, as a liquid. And so now we have our balanced chemical reaction. We got to go back and do the actual problem. 2.0 grams of sulfuric acid. How much mass? So we know mass is in grams, so question mark grams right above sodium carbonate. Start with what we know, 2.0 grams of sulfuric acid. That's our known. We're going to place that over 1 so that we can keep everything in a line. We're going from grams to moles, so we have to divide by our molar mass. Moles goes on the top because we're converting to moles of sulfuric acid. Molar mass of sulfuric acid, 1 times 2.01 plus 32.06 plus 4 times 16.00 gives me 98.08 grams. So if we canceled right here and stopped, I would have moles of sulfuric acid. I need another conversion node because I want to get to sodium carbonate, so this time I'm going to use the mole ratio. Mole ratio is unknown coefficients. How do I know that's the unknown coefficient? Because that's the one with the question mark, over the known coefficient. So 1 over 1. 1 mole of Na2CO3 equals 1 mole of H2SO4. And in that respect, now I can cancel moles of H2SO4, moles of H2SO4. Because remember, we can cancel units and species when we're doing our stoich. Okay? So if I stopped here, my answer would be in moles of sodium carbonate, but I want grams. So I got to go one more time. To go from moles to grams, I'm going to multiply by molar mass. So 1 mole of Na2CO3 is going to be on the bottom, and the top 22.99 times 2 plus 12.01 plus 3 times 16. If you don't know how I'm getting the molar masses, go look up a molar mass video so you can get that. 105.99 is my molar mass, so that's the number of grams in 1 mole of sodium carbonate. And then that cancels. So what do I have left? 2 times 1 times 1 times 105.99 grams. Remember, that's still left there. So that's what my numerator is now going to be. My denominator, 1 times 98.08 times 1 times 1, which is 98.08 is my only thing really left. So I'm going to combine those terms. 2 times 105.99 divided by 98.08 leaves me with 2.161297 grams. Substituted, solved, and now I have to do my sig figs. 2 sig figs here, because when there's a decimal, the trailing 0 is important. So I just need 2 in my answer. This is a 6, so I need to round up to 2.2 grams of sodium carbonate is needed to perfectly balance 2 grams of sulfuric acid.